lecture notes, and I'm going to keep that for you as well.
Perfect.
So let me go ahead and share the screens here. Okay, so you can see my screen now, correct?
Absolutely.
Okay, can you see my my word pad now?
Where it says Monday, June 1st?
Yep. Do you see this thing? Do you see me writing?
Yeah. It's a little laggy. I see test.
Okay, so it's a little laggy. So sorry about that.
I don't know
Because
if it's you. It could be me.
it depends. It depends. But I'm going to stop sharing my face so that way it's not going to be as laggy. So hopefully that helps out with you, and that way we can get you squared away. But even if it's running like a second behind when it presents, you can still hear my voice. Okay, correct?
Yeah.
Okay, good. So which ones can we work through, Kevin?
Well, I don't really have the quiz handy. I could go round it up, but it was definitely questions 19, and 20.
Okay, no problem. Let's go ahead and look at the quiz.
It was it's the one where we shade.
Here, we got it. Do you see the quiz all right, Kevin? Is it populating on your screen?
Yes, I see 10 and 11 right now.
Yeah, perfect, perfect. So which one so one of these? Number 17, did you get number 17?
I mean, I did them, and I don't know if I got them right, but 18 and 19 were definitely, I was like, I don't know what I'm doing.
Okay, no problem. I completely understand. Let's go ahead. I'm going to snip this.
I'm sorry.
No, number 19. Okay, so not this one.
So, it might have, but
so this
right
one?
now, these are my concern, because I have zero idea what to do with them.
Okay, no worries. This was from our chapter, so I'm just going to take this. And let's go ahead and put this in here. Can you see that all right, Kevin?
Absolutely.
Okay, good. So let's go ahead and work through this. And this was definitely a little bit more difficult. That's the reason why I put this quiz up here. I know that it seemed a little bit overwhelming, but again, with this fast 6-week semester, we're covering what we normally do in a week and a half in all of one lecture. So we're going through this real fast. So with this one, when we have to graph this, we have two different inequalities. Do you agree that we have two different inequalities, Kevin?
Agree.
Okay, good. So what I like to do is I like to draw my axes. And I'm going to draw my axes on here. I'm going to do my axes in black. So I know my vertical axis is equal to my y-axis, and my horizontal axis is equal to my x-axis. Do you agree so far? Okay, great. So now what we can do, Kevin, is that we can go ahead and we can graph this first one. So I'm going to graph this one first. I'm going to do it in red. But when I graph this, I'm going to graph this as if it was equals to. So I'm going to graph this first one as y equals to negative 2x plus 3. So the reason why I'm going to do that is because I just need to plot points. But I need to remember, what I need to remember, though, is that in this, I have a less than. So with a less than sign, Kevin, am I going to get a dotted line or a solid line?
I'm unclear on it. I can't remember.
Okay, so the way that I think about it is a less than isn't as strong. If we were to look at less than versus less than or equals to, which one includes more answers?
More than.
Well, which one would have more solutions? The less than or the less than or equal to?
Oh, less than and equal.
Yeah. So that's sort of, I think a solid line is going to be more inclusive versus a dotted line. You don't include as much.
Well, plus there's a line under that one, right?
Yeah, exactly. Maybe the line could help you remember. Whatever way works for you. If you have a less than or equal to or a greater than or equal to, you're going to get a solid line. If you have a less than or a greater than, you're going to get a dotted line on the graph.
Okay, so if there's a line, draw a line. If there's no line, draw dots. Got it.
Exactly. So if it's less than, not as inclusive. If it's less than or equal to, we got some more. So notice for this one, I'm going to jump ahead in a second. For graph number 2, hopefully we can see that. For graph number 2, and I'm going to do graph number 2 in blue. Notice here we have a greater than or equal to. So will this get a dotted or a solid line?
That would be a solid line.
Yeah, so this one's going to get solid. And this guy over here, Kevin, is going to get a dotted. Okay. So that's going to be our first step. That's going to be where 20% being able to identify all of that. Does that help you a little bit?
That helps. Yeah, okay, so far so great. Yeah, that was easy fix.
Yeah, so we got that. So we're on the right path. So now let's look at our graph. So if we want to graph this, the best way to do so is using a T-chart.
So we have our then you plug and play, right?
Exactly, plug and play. So what do you want to let x be equal to first? Do you realize you want to plug in for x here because it's a lot easier because everything's already solved for y, Kevin?
Right, yeah.
Okay, so what value do you want to pick first for x?
I want to do 0, 1, and 2.
Okay, so 0, 1, and 2. And I'm going to add -1 in there just because I want us to go beyond our bounds of comfort.
Okay.
So we're going to add negative. So plugging in 0. -2 times 0 gives you what?
Negative 0.
Plus 3 gives you what?
This is plus 3.
Perfect. Let's plug in 1. -2 times 1 gives you what?
-2. So it's going to be 1.
Perfect. How about for 2?
2 is -1.
Try again. Oh, yes, perfect. Yeah, -1. Excellent. And then how about -1?
-1 is, let's see, that's 5.
Perfect. Excellent job. So now I'm going to plot these points. So maybe if you have a piece of paper handy, you can plot them too. But we have our first point at 0, 3. So that's going to be up there. Do you agree that's going to be there, Kevin?
0, 3, absolutely.
1, 1, we're going to have a point right here. 2, -1, we're going to have a point right here. And then -1, +5, we're going to have a point right up here.
And not only that, the rise and run works with that as well.
Exactly. You can do rise over run. So if you want to start at 3, go back, go up 2, and then back 1, or go down 2 and over 1, either way works. So I like to personally plot points. That way I don't make any mistakes. And on your test, I'm actually going to ask you to graph given the following points.
Okay. So, I mean, it's not a good way to go with the y-intercept by using the 3, 0.
It's not a bad way. It's just not as exact.
Okay, yeah, we want to be exact.
Yeah, that's the whole point of math. You want to be as exact as possible. And I'm sure probably what happened is that maybe in another class or maybe in high school or a different college or university, they maybe said, start with your value of 3 and then count backwards, go back 1 up 2, back 1 up 2. It gets confusing and you're not exact with points. But here, you demonstrate, if you did this on your exam, you demonstrate to me that you understand how to find these coordinate points. You get another 2 points, plus you get your 1 point. So right now, even if you don't have the rest of it, you still got 60% correct. Do you see the difference?
That's really good because I got all that. I got the T-chart. What I didn't get is any of the other stuff.
Okay, let's work through this. So when I connect these points, Kevin, in red, am I going to use a dotted line or a solid line?
We're going for red, so that's dotted.
Yeah, right. So I would have to connect these using. Okay, I should have been better. Let me make a better dotted line. Okay, it's a little tough to draw on my little pad here, so I'm going to try.
I get the point.
So I'm going to get a little dotted line here, so hopefully I can figure out how to do it. That's supposed to be a dotted line intersect. Let me try one more time. Yeah, it's a little. I'm still getting used to writing on this little pad here. So, right now I'm going to start here, and I'm going to go down. So something to that effect. You have a red line that's dotted, and it's supposed to be a little bit more even, but not perfect.
I get the gist.
So now what we have to do, which is a little different because it's an inequality, we have to check a point. Kevin, what is the easiest point to check on our graph?
I think you're wanting me to say 0, 0, but
yeah, 0, 0 is always the easiest because that's at the origin. So as long as our line does not run over 0, 0, does not intersect 0, 0, we can check 0, 0 to see if it's true. But we're going to plug into our original one. So plugging in, is 0 less than -2 times 0 plus 3? Is this a true statement or a false statement, Kevin?
That is true.
Yeah, this one's true, exactly. So since this is true, am I going to shade in the area including 0, 0, or am I not going to shade it in?
Since it's true, we want to shade in the 0.
Yeah, exactly. I agree with this. So I'm going to shade in all this area right there to the left.
Okay, so I wasn't doing any of that plugging for 0. So okay.
So you can test any point that you want to, but I'm going to shade in that area.
Okay, got it.
Okay, but here's on mine's it's a little bit smudgy. Let me try a highlighter instead. Let me try a highlighter so it's easier to see the points. So I'm going to draw a highlighter. So I'm going to do a highlighter in yellow. So let's see if this this actually is a little bit better. So I'm going to shade in this portion right here in yellow.
Okay.
So these are all the points I'm including. So right now for this, Kevin, everywhere in shaded yellow, I'm going to include that for this part of the solution. So right now we got half of the question correct.
Okay.
Do you agree so far?
Yes, sir.
Okay, great. So now since we tackled the first half, we have to tackle the second half. So now we're going to have to look at the second half, which we're going to do in blue. We're going to do a blue, and we're going to graph y is equal to 2x plus 1.
Okay.
So we're going to replace that with greater than or equal to, and we're going to have x, and we're going to have y, and we're going to do the exact same thing like you did before. So here I'm going to let 0, 1, and 2. I bet you're going to try that one out. And I'm also going to add -1 Tell me what you get when you plug these in, Kevin, to make sure we're on the same page.
0, I have 1.
Perfect.
For 1, I have 3.
Perfect.
2, I have 5.
Yep.
And I haven't got the -1 part.
That's all right. So I guess you were working ahead. That's great.
-1.
-1, exactly. So now I'm going to plot these ones in blue. So at 0, 1, I plot this point right there. At 1, 3, 2, 3, 1, 2, 3, I have this point right here. At 2, 1, 2, 3, 4, 5, I have this point right here. And then at -1, I have the point -1.
Okay.
But now, are we going to use a solid line or a dotted line, Kevin?
Solid, because it's equal to.
Yeah, exactly. Greater than or equal to. So we're going to use a solid line. Let's see if I can do this right. So I have a solid line. That was a little bit easier than the dotted one. So I have a solid line. So notice here we have a solid line. The last one we had dotted. So we have some serious differences going on here. So so that's good. So we figured that. So now we have to check a point. What is the easiest point to check in this circumstance, Kevin?
0, 0.
Yeah, 0, 0, I agree. So checking 0, 0, let's see if we get a true statement. Is 0 greater than or equal to 2 times 0 plus 1? Is 0 greater than or equal to 1?
That's a false statement.
That's false. So are we going to include the area that includes 0, 0 to the right of the line, or are we going to go to the opposite that does not include 0, 0?
Doesn't.
Yeah, exactly. So I'm going to show that area. I'm going to show that in green. So here I'm going to shade everywhere to the left. So I'm going to shade everywhere to the left. So that's going to be, pardon?
True includes and false discludes, right?
Yeah, exactly. If it's true, then we're going to go everywhere to the left. If it's just, oh goodness, I somehow deleted it. If it was true, we'd include it. If it was false, we would not include it.
All right. So
now the question is, now we have to throw in this little and. Of course, we're not done yet. We have to throw in this and. So if I think of and, Kevin, and, does and mean, are we overlapping? Are we overlapping? Or are we looking to see where our two graphs overlap? For example, if I have blonde hair and blue eyes, I am looking to where they overlap each other. You have to be one person that has both of those. For anyone that has blonde hair or another person that has blue eyes, we're looking for more of a opportunistic example. So that's where they would equal or. So in this circumstance, am I going to look to where, since it says and, am I going to look at where they overlap, or am I going to look at where they all share the same answer?
Where they're unified.
Exactly, union, exactly. Union's the key word here. So if I want to look at where they are unified, I'm looking to where they overlap.
Okay.
So now, do you see where they're yellow and green? See how it's sort of split up into 4 quadrants? I have 1 quadrant, 2 quadrants, 3 quadrants, and then 4 quadrants. Do you see how I sort of have 4 quadrants made by this graph, Kevin?
Yes, sir.
So now, where they're unified, I am going to do that. We'll do that let's do that in red Sharpie, or we'll do that black Sharpie. So notice here, it's going to be starting here, following, going down here, and it's going to be everywhere that we see in this black marker. So it's going to be this area right over here.
Okay.
So that's where,
on the test?
pardon? Yeah, something to this effect. So you would shade in what I just shaded in, something to that effect.
Okay.
So how would this have changed, Kevin, if I didn't have an and here, if I would have written or? How would this have changed?
Or? That would have been it's the I word. It's not the union.
So it's where union. You're right. So intersect. Is that what you're thinking? Intersect. So it's still going to be intersect. Intersect and union. I get what you're saying. So if it was or, I'd be conjoining all of my areas together. So it'd be where it's yellow, green, all together. So we would have 1, 2, 3 sections.
Right. That's intersect, right?
Yeah, that's intersect.
Okay, yeah. So it'd be intersect, whereas that section 2 on there, nothing. Got it.
Exactly. So if this was an or, it'd be sections 1, 4, and 3. But since it's and, it's just going to be section 4.
That's much clearer. I get it now.
Does that help you?
Yeah. With the next one, it just has 1. So do you just do a line just like you would the first one?
Yeah, absolutely. So let's go ahead and look at that. Pardon?
It's actually easier?
Yeah, it's actually easier. So let's go ahead and look at this one. Okay, I'm going to snip that for you. Okay, so let's go ahead and delete that. Okay, so here, do you see that problem, Kevin? See if I can
Sure.
make it bigger. Okay, there we go. So now we're going to do this guy. So if we just have to graph one, this should be pretty simple. We should have this down to a science by now. So let's go ahead and just graph this one. So if we're going to graph this, we have to think about a couple different things. So we're going to have to set up some axes. I thought I was going to set up axes. I thought I could draw a straight line. There we go.
I got your answers ready.
Oh, you already got it?
Yes, sir.
Great. So you work it. I'm going to work it. You tell me what to do. So I got my axes here set up. Figure out how to draw equal one.
Well, we're going to need X and Y chart.
So we're going to do an X and Y chart. Exactly, Kevin. So we're going to have an X and Y chart. What'd you do?
0, 1, 2, and -1.
Okay, great. So you checked 4 points. I love it. What'd you get for 0?
I got 3, then
Yep.
5,
Yep.
7, and +1.
Perfect. So here we got 0, 3. So I'm going to go 1, 2, 3. My first point, 1, 5. So I'm up, what is that about? What? So 1, 2, 3, 4, 5. So right here. Then I have 2, 7. So I'm up here. And then lastly, I have -1, 1. So I'm here. So am I going to use a dotted line, Kevin, or a solid line?
I'm going with dotted.
Yeah, dotted because it's only a less than. So here we're going to use a less than. So I mean, we're going to use a dotted line. So here I'm just going to connect these points best I can using a dotted line, clearly indicating that it's not solid because it's only greater than, it's not greater than or equal to. So now we have to test a point. What point do we have to test, Kevin?
0, 0.
0, 0. So let's test 0, 0, plugging down to inequality. Is 0 greater than 2 times 0 plus 3? Is 0 greater than 3, Kevin?
No.
False. So are we going to include the area of 0, 0, or are we going to include everywhere else?
Exclude.
Yeah, we're going to exclude it. So it's going to be everywhere to the left or the right of our line.
Left.
Yeah, so I'll do that in blue so we can see it. So it's going to be everywhere to our left. So you shade in that area right there. How easy was that?
It was actually way easier than I thought.
A lot of times people overcomplicate this stuff, and maybe it's just a little overwhelming, but it's really not so bad.
Also, the Mike's Way one, I know I was supposed to use that.
Yeah. No worries.
I would just plug it. It had to have been on the test somewhere. I just didn't know where to use it at.
Yeah, no problem. We can do it. So let's go ahead and so it's just right. That's just writing an equation of a line. That's just the way that I give everyone to write an easy equation of a line. So writing an equation of a line. So the form goes, if you have m equals to a over b, positive a over b. So where m is your slope and the slope is equal to a value a over b. So an example here could be positive 2/3. Okay, and if you intersect the point 1, 2, and this is still going to be intersect the point 1, 2.
Okay.
So we have two different situations. One, I'm using a or b. So the rule states I take the numerator of my slope, I put in front of the x. I change my sign from whatever it is to the opposite. So we always change our sign. Positive will change to a negative. The b will then go in front of the y.
Right there.
You agree?
The y.
Yep. So now all we do now is plug in. So we have a, x, but x is equal to what in this circumstance, Kevin?
It's going to be 1.
1 minus b times whatever y is, and y is what?
2.
2. So this will just be ax minus by equals to a minus 2b. That's how we could do it ubiquitously for a slope that is positive a over b. Let's try this 1 2/3. Ready? The 2 goes in front of the
a or y.
x. Always the numerator goes in front of the x.
X,
The sign goes from positive 2a. Positive
to the negative, but the x goes. I thought the y was always on top, but that's just your way.
No,
right?
just think x over y.
Okay,
X, I think, in terms of your alphabet, x comes before y. Numerator comes before the denominator.
Okay.
So 2 goes before x, 3 goes before the
y,
and we always change our sign. Now we just plug in 2 times x, but x is equal to?
X is equal to 1.
Yep. Minus 3 times y, but y is equal to?
2.
2. So this will give us 2x minus 3y equals 2 minus 6. So 2x minus 3y equals to negative 4. So that's going to be the equation of the line that has a slope of positive 2/3 that connects through the point 1, 2.
Okay.
So how about you try an example and see how you
I
do?
get that, and that's not the problem. It's I don't know when I'm supposed to implement that.
Whenever it asks to write an equation of a line, if you ever have to write, if it ever says write an equation
Okay.
of a line, in order to write an equation of a line, you need a point and you need a slope.
All right. I'm sure that was on there somewhere, but I didn't.
Yeah. So if we let's look at it, see where we could have used this mechanism. So
Okay.
notice, okay, we'll go to an easier one first. Okay, so here we have to write an equation of a line. So notice here, what does it say, Kevin? Equation of a line.
A line that has a slope of m equals -2/3 across the point 30. So we got our point and our slope.
Exactly. So let's go ahead and try this one out together. We'll do this one together and see how we do. So let's go ahead and, are you able to hear me all right, Kevin?
Yes.
Okay, good. And you're following through all right with the lecture, with the notes?
Yeah, absolutely.
Okay, good. I've only been doing these virtual office hours now for like a couple weeks, so I'm getting used to them.
Do you like them?
Oh, actually, I like being able, like, I can tell you that, I've held office hours for years since I've been teaching, and I'd probably say during any class, maybe I'll have a dozen to two dozen visits. But through these virtual office hours, I've had probably now nearing the 50 of visits for just my summer class, because people, it's weird because you don't have to, drive on campus, find a parking space,
Right.
find my office, come talk to me, unload your gear. So you could be sitting at home or at work or wherever, and we can do virtual office hours. So I think it makes it more accessible for people. So that's my personal opinion, but I don't know.
Constricting to you.
Pardon?
Does that make it more constrictive to you, though?
No, because like I held virtual office hours. I was in my clinic last night when I did my virtual office hours last night. So I was at my clinic when I did them. If I need to, I can always I can show you, like I have a webcam. I'll show you what it looks like. So I can start a webcam, which is really nice. Some people like the webcam. Some people don't like a webcam, but it just makes it, I think, more accessible for people. So I'm not sure. I hope people like it. I'm not 100% positive, but
I like it.
Well, that's good. That's the important part. That's the important. As long as you get it, that's all that matters.
I was literally trying to teach myself this by using Google and stuff the whole weekend, and I couldn't do it. So.
Well, that's why you need to ask me. You need to shoot me an email. How fast do I respond to those emails?
Pretty quick.
Yeah, pretty quick, because I'm all about getting back to you. So so that's a big thing for me, is being able to get back to you. So because I understand this class has to be quick, and we're almost done. We're literally halfway through the semester. So if you ever have questions, you always make sure to ask. Let's work through this question together, okay, Kevin? So here I have a slope which is -2/3, and I'm crossing the point at 3, 0.
Perfect.
Okay, ready? What goes in front of the x?
That'd be the 2.
2. And our sign goes from a negative to a
Positive.
positive. What goes in front of the y?
3.
And this equals to 2 times x, but x is?
X is 3.
Yeah, plus 3 times y, but y is what?
0.
So I have 2x plus 3y is equal to 2 times 3, which gives you what?
6.
3 times 0 gives you what?
0.
6 plus 0 is what?
0. 6.
Perfect. How easy was that?
So that's what you wanted, that finished line right there.
Yeah, and this right here is called the standard form. So this right here is called the standard form.
Okay.
Oh, yeah, that's okay. I have another point I forgot. I'm going to bring up to you in a second, but that's called standard form. If I wanted slope-intercept form, this is going to be in the form of y equals to mx plus b. So if it specifically asks us for slope-intercept form, we're going to have to convert this and solve for which variable, Kevin?
The y.
Yep. So here, the first thing we're going to do is I'm going to start off like this.
You just flip everything to the other side, right?
Yeah, I'm going to solve for y. So now I'm going to have 3y equals to -2x plus 6. So notice the mx, which is the slope, mx plus b. So now I have to divide everything by what, Kevin?
3.
3, yeah. So I'm going to divide everything through by a value of 3. So I have y equals to -2/3 x plus 2. So notice here I get the slope, and my slope I found to be through this form is -2/3. And is that what I wanted it to be when I started off, Kevin?
Yes, it was.
Yeah, so that gives us a good answer that we were on the right track.
Okay, cool. Yeah, that's excellent.
Good. And I thought of something else. I have to stand corrected because when we were doing this problem over here, I think I said it wrong. I don't know how I said it, but I just thought union. Okay, so if we think of and is synonymous wherever these guys overlap. And I think we said before that if we talk about the and is where they overlapped. So that's why we have to worry about these all being intersect. This is where they overlap or intersect. If we talk about the union statement, the or is union. So we're taking, for example, when two people get married, when I get married to my wife, if I have $10 and she has $40, we unionize our assets and together we would have $50.
Okay.
So whenever I have an or statement, whenever we have an or statement, that's a union statement, and that's going to be putting everything together. So or is union, putting it all together.
So I had it backwards, is what you're saying?
Yeah, and I think I went with you on that. So I'm not exact. I guess I can listen to the video and see what I said. But it just hit me a second ago. So for this statement, if it says and is wherever they overlap, wherever they overlap.
Okay, so it's not including everybody's stuff. It's just where it's over. Got
Exactly.
it.
So exactly. If it was or statement, you think of unionizing two different groups. So we're going to take this section in 1, this section in 4, and this section in 3, and putting it all together. So
Right.
or is union and is intersection.
Mm-hmm.
So I don't know if I said that. I just want to make sure I said that correct.
Yeah, I'm gonna have to remember that properly now.
Well, I'll send you this video. So if it's incorrect, you can correct it. But I'll also send you a copy of these notes too.
Union is everything. I just need to know that.
Yeah,
Because it's mine and yours.
yeah, exactly. Union or whatever we
Just
have.
where it goes over. Got it.
Exactly.
Okay.
Okay, next question.
I mean, I'm gonna. You're probably gonna go over this whole quiz, aren't you?
I'm going to go over any questions that people have from the audience, but I completely applaud your efforts to understand it before I start class, because that way you're not learning it for a first time. You're just reviewing what you already know.
Okay.
So I think it's a good idea just to do what you did and try to get as much information down before you even start the class. So never feel bad about going over something with me separately that we're going to do in class, because you didn't know what if we were going to do it in class or not. I just so happen I'm going to go over this because this is pretty important for us to know. But at least you have a good idea. So when we go over it again in class, you're going to be reviewing what you already know instead of having to learn it for a second time.
Oh, I do have another question. Do you
Sure.
post when the next homework assignment's due yet?
Our next, yeah, if you go online and let's go ahead and pull it open and look. So let's go ahead and pull open and look. Can you see the Internet Explorer, Kevin?
Yeah.
Okay, so if we go to your class, so here, it's weird. So notice here, the next one's going to be in 2 days. So it did update last night.
Okay. Yeah, because I was wondering, because I mean, I also saw the quiz, and the rest was like a month away. I didn't know.
Yeah, well, I didn't want to overload people with so much to be done, especially with that quiz, because that quiz was a pretty big It was a voluminous quiz. It covered 10 sections.
It was pretty intense. I ain't gonna lie to you. It took me
Yeah,
about
but that's
a day
what-
and a half to finish it.
Well, we had it was posted on Thursday, right?
Yeah.
So Thursday, Friday, Saturday, Sunday. That's 4 days to do it. I think that's plenty fine with a.
Oh yeah. No. I was just saying it was intense.
Yeah, but
I
so.
was agreeing with you.
Oh, okay, that's good. Well, I'm glad we were in agreement. But that's going to be due. These next ones are going to be due on the 3rd, on June 3rd. 5.4, 5.5. I mean, 5.4 will be due on the 7th, and then we'll see how we do over the next 2 days before we start assessing any more due dates.
Okay. Scroll back up again.
Okay,
so was it 6-3 is the next? How many chapters? 5.
we're going to have 3.2, 3, 4, 5, and 6 will be due on the 3rd. So Wednesday night.
1, 2, 3, 4, 5, 6. Okay, 6. Okay, got it.
So we should have already finished most of these because 2, 7, and 3, 1 were due on the 27th, the day before our last class. So we should have been working ahead on these 3. But I don't like to do too much of because we did cover everything from 3.2 to 3.6 last class.
Okay.
So we're going to do 4.1, which is where our first test may or may not go, but we'll talk about that today in class. But 4.1, we're probably going to get all the way to 6.1 today.
All right.
So notice here we only have about 11 more sections left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sections left. So we're almost done.
And then we just review until the class is over, right?
Yeah, then we just review till the class is over. Exactly. So we'll have 1 day of review. So our last day, we don't cover anything. I just come in, I do any question you guys want.
Perfect. I'm going to take a break before class if that's okay.
Absolutely. Well, I have to walk over to class because I'm in my office right now. But are you good with questions before we go?
If I do, it's going to have to not be today.
No, that's all right. Kevin, can you do me a favor? And do you see on the thing? Can you type me your email address? And what I'll do right now is I'll PDF this for you. So I'll send it to you right now. So
Absolutely.
let's save this as a PDF. So you are Kevin Collins, right? Kevin Collins. So 6-1. So that way you have a copy of all of this stuff. Oh,
Probably can't put those dashes.
yeah, I always forget. Okay, so now, what is? Can you type your email address for me so I can just cut and copy it? It makes it easier that way I don't make any mistakes.
Absolutely.
Thank you so much. Okay, great. Do you have a student one? Do you have a student email account? Do you use that one?
I never use it, but you can have it if you want.
Yeah, try that. We're supposed to communicate via student email. It's the only thing that's actually privileged between faculty and students. So I know it's secure because I don't always, even though Kevin MT Collins does sound like you, it's not actually secure communication between the instructor and the student because of these privileges with FERPA, which is this Federal Education Rights and Privacy Act. I can only really communicate through your student email address. So do you have that one?
PensacolaState.student.com.
It's at students, yeah. So whatever your login is, I can do the rest of it. Just give me that login.
AMC 1221 is coming your way. Though. Let me erase this.
Oh, great, thank you. KMC, perfect. So I will email this to you right now, and that way you have a copy of the notes. And then I'll open up the next one at around 6 o'clock. So Kevin, just an FYI, I know you live in Fort Walton right now or Niceville. I mean,
Santa Rosa Beach.
Okay, Santa Rosa Beach, but you do know for the test you have to come back on campus on Wednesday, right?
Yeah.
Okay, sounds great. Well, I will see you in class, Kevin. What did you think about the virtual office hours?
I loved it. It's perfect. I do have one question. How do I log into the class?
So you know how? So you're going to go back to. I'll show you. So well, actually, I'll just open it right now. So I'm gonna end this. Oh wait, no, I can't end that because then it would end.
We're kind of.
Yeah, so I can't. So right now I had the virtual office hours which I created for you. I'm going to end those now. So see how that populated? I'm just going to go ahead and start the conference for tonight's lecture. So, and you're going to get an email to yourself, so you can always click directly on the email link. Lectures 6/1/15. So see how we just populated earlier? So now we go back to the website for this class for 1033, not for the office hours, but for 1033. Intermediate algebra. It's going to be lecture 6/1. So you're just going to click on that just like we did before.
Okay, perfect.
Does that make sense?
Yes, it does. I'll see you in about 10:15.
Sounds great, Kevin. You take care.
Will do.